Hello everyone. Today I will talk about something about STATA, how to use the file in STATA and how we can prepare our file for data analysis using STATA. And during this tutorial, I will explain you how to maintain a do file, how to import Excel file into STATA, how to generate variables, new variables, and how to define categories, and how to label and code data, and how to run frequencies and other indicators like mean and ranges. So for this, first I have to share my screen, and yes, so you can see STATA here, and this is a STATA, and I just opened the window of STATA. And to import an Excel file into STATA, I have to go into File, then Import, and then Excel Spreadsheet. Then I need to go to Browse, and my file is here. You can choose your file from the destination where you have saved your file, and my file is here, so I choose it and open. So now this, you can see this is my file, this is the data, and you can see this first row is my variable's name. And if we want to keep this variable name as it is, we need to check this import first row as variable name, so it will remain same, and then okay. So now you can see these are my variables, and if I want to explore my data and I want to see my data window, I can see from here data editor. So this is my data, and also I can see by command BR and enter. So the window appears, which is data editor. Close. Okay, so the first variable is gender, which is of course male or female. And if we want to see gender, BR gender, double click gender, and you can see gender. So gender is coded as 1 and 0. So let's suppose if 1 is male and 0 is female. So how we can label it as male and female? So just close it, and I want to see the distribution of 1 and 0, and for this I need to write TAB tab and select gender and then enter. So you can see here 0, which I consider female, is 681, 58%, and 1, which I consider male, is 489, almost 42%. So it appears as 0 and 1, but if I want it as male and female, so I need to label it. For this, I need to write LAB label, define DEF, then my variable gender. So I want 1 as male, inverted commas, and 0 as female, inverted. So you can see here LAB label, space, DEF define, then a space, select your variable, and you can write also, then a space, and 1, which I mentioned earlier, indicates male, and then inverted commas male, inverted commas close, and 0 is for female. So that just I enter it. So it label it as male and female. If I want to explore again my data, BR and gender. So okay, so I need to label value. So if I want to see the here male and female, I need to write LAB label value and select this variable 2 times and enter. So now the values labeled, and we can see again by exploring through BR command, and you can see male and female clearly here. And if I want the frequencies again, I need to write tab and select the gender, and you can see the same frequencies with the labeled 0 as female and 1 as male. So here I also would like to tell you that you should maintain a do file. So it would be helpful for you to just copy and paste the commands for any of your data analysis. For this, you can open new do file editor and you can save all the commands from here, like BR or BR gender or tab gender, copy and say paste into the do file. So you have to remove these dots. So like if I want this command, I just copy it. I want to see the frequencies, I just copy it, paste here, and you can see it will provide you the frequencies. So this is for changing the label in the same variable. But if you want to make another variable and keep this variable as it is, so we can do it also. And for this, we need to generate, like if I want my data to be 1 and 0, the master file as it is, and the master variable as it is, and I want to make another variable in which I would like to define the codes and label, so we can make another variable for this. Generate to GEN, then space. Again, I want gender. You can write whatever you want to give new name to your variable. I want gender underscore 1, then is equal to dot. So it generates a variable. So you can see we have 1170 total observations, and you can see here this data generate gender 1 variable which has 1117 missing values because we have not defined our values into new variable. So you can see if I want to explore this variable, no data is here. So these are missing values. Then I will give them values like I want one. So I do it by replace my new variable into 1 if the previous variable, which is gender, is equal to 1. So I replace all the 1 into the new variable as it is 1. So you can see here 489 real changes and 1 indicates male. So you can see 489 changes appears here. Now I want to replace again my new variable is 2. I give 2 code to female. If you remember here, the female code was 0, which is not an appropriate code because we usually use 0 to define no. If we have binary categories, yes and no, we always use 0 for no. And for like gender, so we can indicate 1 is for female or 1 is for male, and 2 is for female or 2 is for male, which is appropriate and which you would like to give. So here I replace 2 if gender is equal to 0. So 681 real changes made. You can see here it also cross-checked by this variable. So now I label it again. So I label it again by write the command of lab label, then define, then my new variable. Now I am working on my new variable. So I want 1 to become male, again same process, and here instead of 0 I use 2, so which is female. Okay, now I give them values, label, value, and select the new variable twice, and you can now tap the new variable. So these are the 2 methods. You can change your label, and you can define your label and values into STATA by working on the same variable and by generating another variable. So this is for the binary variable, and you can now again copy these commands and paste it into the do file. Again, please remove these space and full stops, otherwise this commands will not work. Okay, so now let's explore the continuous variable, which is age. So if I would like to explore the data, how ages are entered, so I again write VAR and age. And you can see here, these are the ages. Now I want to find mean and range of my ages, so I need to write the command summarize, which is SUMMARIZE, summarize, then select the variable age and enter. So you can see here, these are the total observation 1170, and the mean age of this data is 49.7 years, and the standard deviation is 8.7. The minimum age is 33 and the maximum age is 68. So this is the range. In this data, the ranges are between 33 and 68. Okay, so if I want to explore this quantitative data in detail, I need to write the same command, summarize, select the age again, then comma, and detail, DETAIL, detail. Now You can see here the mean and standard deviation, and these are the percentiles. If you want to make your age variable as a categorical variable and you have not clear about the categories ranges, so one of the method is to look into the percentile and then make the categories accordingly. Like if we can see 25% of the data contain the ages between 35 to 42. Again, the 25th to 50th percentile contain 42 to 49. Then 50th to 75th percent data contain ages between 49 to 57, and above 75 contain the data more than 57. So we can make 4 categories from this data, which and the categories will also be um, appropriate, like there will be no sparse data and unequal distributed data. If we go through this percentile method, we will have similar equal uh, categories and equal numbers in all of the categories, more or less similar. So first of all, we need to again generate, for this we need to generate another variable. So GE and generate, then I want to name it as age, and there is for cat is for categorical, then again is equal to n dot. So here you can see generate, the variable is generated, and the variable has 1117 missing values. Now we will define our categories. So how we can define it? So you can see here, I write replace. I will use the previous age variable and replace it according to the ranges which is mentioned in the percentile and make my own categories. So you can see I write here is replace age category 1, age category into 1. So this is my new variable. So it will give if the age variable, I use the first categories all with less than 42 years. So I write less than 42. Sorry. Replace age category is equal to 1 if age is less than 42. So I have 261 observation whose age are less than 42 years. So this command replace all 261 observation as 1 into the new category. Now, my second category is age between 42 to 49. So I write the command replace age category is equal to 2. Now my next category is labeled as 2. So my first category is less than 42. Now I will use the range between 42 to 49. So I write here if in range, then bracket, select this previous variable age, then comma, and I want between 42 and 49, and again bracket close. So you can see here I use replace age category 2 if in range age 42 to 49, like simple. It replace all observation into 2 in the new variable, all those observation who lie between 42 to 49 years. Now enter. So 337 real changes made. It means 337 observations have the age between 42 to 49. Now my third category will be between 49.1 to 57. So now I again write, and I can also select the command from here, and I change 2 is to 3 because it is our 3 category. I write here 49.1, and here I write 57 because we use for between 49 to 57, 49.1 to 57. And now you can see 300 real changes made. So our 3 categories have the observation which have ages between 49.1 to 57. Now our last category, because now we will not use the range, we can use the first command in which we use less than, here we use more than. So it is our fourth category in which we use more than 57. So our last boundary is 57. So now our next category will have data which have ages with over and above 57. So 272 real changes made. So in this data, 272 observation have ages more than 57. So now I define label here. For this, I again write label, then define label, then define, and our variable name is, now we will define label into the new category because it is our categorical variable. However, the first one is continuous variable. So we have 4 categories. So we want, so first I would like to show here how these categories appears if we did not label it. So you can see it's 1, 2, 3, 4. So if we will not define the labels, we have no idea about which category is reflecting which age group. So for this, we need to define the label of each of the category. For this, we need to write label, then define, then select our new variable and write here 1, which I want, and we use the boundary less than 42. So I write here 42 years, inverted commas close, then 2 is between 42 to 49 years, inverted commas. Those 3 is for 49.1 to 57 years, and the fourth one is above 57 years. Close inverted commas and enter. So these values will be defined as 1 is 42 less than 42 years, 2 is 42 to 49, 3 is 49.1 to 57, and 4 is more than 57. Now I label the values. For this I need to write LEV, label values, and select the new variable twice as we did earlier and enter. Now we can explore how it appears if we write tab and select our new category. So you can see here less than 42 years 261, 42 to 49 337, 49.1 to 57 300, and more than 57 272. So similar frequencies and percentages, but now we have proper labeled data. So this is how we can generate new variable from our previous variable, how to define the categories and how to label and define the label within the category, and how can we explore data and how we can explore the frequencies and percentages and the other mean, standard deviation, ranges, and the percentiles of the quantitative variable. So now let's work on another variable, which is, let's do it on current smoking status. So now I want to explore this variable. For this I write tab and select this variable. So you can see current smoking, which is defined as 0 and 1. Definitely 0 is for no and 1 is for yes. I also mentioned earlier we always use 0 for no and 1 for yes. So if I would like to replace it with yes and no, so I again label, define, then select current smoking. Here I want 1 as yes and 0 as no. Then I value the label. For this I need to write LAB label, then value, then select this variable twice. So I'm doing the changes in the same variable. I have not made another category, another variable for this. So I made changes within the same variable. So now I value the labels and I now again tab it to see. So now you can see 0, which indicate no, is 597, almost 51%, and 1, which indicate yes, is 576, which is 49%. So we can also save these commands. First of all, generate category. You have to make your